All right, hi everybody, and welcome back to part 3 of the Bravo project. In this part, I'll be building a module, which I call it LED board. And again, this is not part of the original minimal project. In fact, on minimal project, we don't have any LEDs except one small LED, which shows the power for the system. However, and to be honest, it doesn't make sense for the minimal project to have any LEDs. Reason being is that you're running at high speeds, and basically when you're running at, let's say, over 1 megahertz, I mean, the LEDs basically will be flashing so fast that you will not be able to see any changes essentially on the LEDs. But in this project, since we'll be building the modules one by one, and we'll be testing those, and also we have the ability to actually run the clock manually, and also we have control over the speed of the clock. For most of the testing that we'll be doing, we actually run the clock at much lower speed, and that enables us to actually see the data and the address lines right here on that and this LED board. Again, this is an add-on module. This is not part of the original project. I have added this module to the project, and essentially it's quite simple. You got a bunch of LEDs, just like that 8-bit computer, Ben 8's 8-bit computer. We had a bunch of LEDs for different modules. The same concept here. You get some LEDs for A and B register. You get LEDs for your bus line, and also for flags for data lines or data address lines, and also here for your control signals. So it is again a bunch of LEDs, and let's build it. And after the build, I'm going to talk a little bit about the logic behind it. So again, it's a speed up video that I'll be building it. I'll be soldering the board. If you like to watch it, you're welcome. Otherwise, you could skip it and go to the description part. We'll see you there. right, so we built the LED board. So let's see what we have here. And so, as I mentioned, the LED board is quite simple. You get a bunch of LEDs for different parts of the project. So, for example, you could see the A register indicated with a from A0 to A7. You also get the B register shown from B0 to B7. You get the bus lines. You get the flags. We have 3 flags in this computer, basically carry flag, negative flag, and 0 flag. All of them have an LED here. You also get the address lines for the memory. This computer has a 16-bit address line for the memory. Therefore, we have 16 LEDs starting from 0 to 15. And then finally, at the bottom, you see we have the LEDs for the control signals. Now, this module is stackable, meaning that we are using the stackable header pins. And if you look at the back, you see that those female header pins are actually extending to this side. So you get the male side at the back, and you get the female side in the front. So that enables us to actually connect that to other modules. Now, in regard to the module itself, as I said, nothing special about it. It's just a bunch of LEDs, and as you can see, we have current limiting resistors, and I specifically use those resistor arrays rather than having individual resistors. Just because individual resistors take more space, and of course it probably costs more than these resistor arrays. These are quite simple. Essentially, these are resistor arrays with 9 pins. 8 pins give you a resistor, and the last pin is just common between all resistors. So let's say that you want to connect 8 LEDs to each of those. So you connect the LEDs to each of those pins. The other side, let's say, is a positive 5 volt, and the common pin and the resistor array will be connected to the ground. And just make sure that if you're getting those resistor arrays, you need to get the bust resistor array, and the bust basically means that they have all one common pin, which is normally the first pin on the left side. So that's all about it. It's quite simple. And another thing that we need to probably have a look here is these 2 chips here. These 2 chips are 74HC04s, and these are basically simple inverters. And I'm gonna describe it why we have those chips here. So in the specific project, when we are building the control logic later, all the signals or control signals that are basically coming from our control logic to different modules are coming in their original form, meaning that if a signal is actually in an active high, it's gonna be transferred to its destination, whatever is the module. For example, let's say that we have A in and A out, or B in and B out, and the destination for those signals obviously are our A or our B register, right? Actually, A in and A out and B in and B out all of them are active low signals. When we generate those at our control logic, they are actually generated as low signals, meaning that in the original computer build, there is no conversion of those. We are not inverting those. I'm emphasizing that here because if you're one of those who have built the Ben Eater's 8-bit computer, you know that Ben moved those signals to a section that has the LEDs for the controls, and then there he actually inverted some of those signals that they were active low, and then he took the inverted signal to final destination, whatever it would be in the build. However, in this computer, we're not doing this. If a signal is active low, it's going to move active low to the final destination, whatever it is. If it's active high, it's going to be active high all along the computer. Now, only for this specific LED board, I'm converting all the basically signals to active high, and the only reason for that is that so that I will be able to light up these LEDs, meaning that these converter signals here are actually just lighting up those LEDs. They have no other purpose, and those two chips here is just for visualization purposes. So in general, that's how it has been designed. I guess this part, which signal is inverted and which signal is active high or active low, it will be part of the control logic that we'll be talking about that in that specific video. For now, it's just important to mention that these chips here are just specific to this card. They are locally significant to this card, and it has no impact on the operation of the computer. So with that, I guess that's really all about it. So I have written a little sketch for testing this board, and essentially it's a quite simple sketch. I'm going to show it to you shortly. What it does is basically just lights up the LEDs one by one. So this way we'll be able to test that actually all the pins are connected, all the soldering are okay, the LEDs are actually okay and they're lighting up, and basically this board is ready to be used as a LED board for our computer. So let's go to our sketch and have a look at that sketch and see how it works. Okay, so we're ready to actually start the testing and run our Arduino sketch, but before doing this, let's actually connect that to our Arduino Mega Shield that we built in previous video. And basically how it works is that, as I said, we have stackable header pins here. So one side gives us the female at the top, and then at the back we have those male pins that could basically stack to our Arduino Shield. So you can line up those pins with the female socket on both sides, and you kind of just push, and there we go. They're stacked on top of each other and ready to go. So now the only thing that remains is just connect our Arduino Mega, and you're gonna stack that at the bottom of the Arduino Mega Shield like so, and I guess that's it. That's ready to go, and we have a little nice build here that we could start testing. Now the only thing that remains is just connect the USB power, which I'm gonna do it right now. So we are going to connect that, and we are ready to go. So let's go to the sketch and start testing it.
All right, so here is the sketch, and we're gonna have a look at the sketch, and I'm gonna talk about different sections of it and how it works. This is actually a good introduction to the whole process that we'll be going through on each module to test it. So the sketch basically has two parts. One part is just a general definition, which we could call it our base code, and essentially that part will be repeated on all other sketches that we're going to be using in testing the modules that we'll be building later. So the first part is basically just some definition and initialization of the variables. So for example, we are actually defining a variable here. That's an array. We call it boss, and essentially we just map the pins that are connected to those boss lines to this variable array. Now, as you can see, for example, in case of boss, pin 23, 25, 27, and so on up to pin 37 are connected to our bus lines, and those are actually the physical Arduino Mega pins that are connected to our bus lines. The same thing for address lines, and those obviously are longer because we have 16-bit address lines, so we have 16 pins on our Arduino Mega dedicated to our address line. So we just created another array there and basically assign all of those pins to our address line. The ADD indicates the address line. Now, for the rest of the pins, since they are not basically sequential, or we could not put them in an array, we just define them separately. For example, pin number 2 on our Arduino Mega is actually our clock pin. This is where it sends a clock pulse to our computer. Pin number 3 is a clock in, and it's basically I dedicated pin 3 so that we could read the clock pulse from the Arduino, so that basically we could, let's say, create an interrupt and read those clock pulses that goes in the system, and based on that run something else. So this is just designated as clock in pin so that we could read it. This plays more like a input pin in our build. And the rest of the pins are the same, and essentially if you look at it, these are the signals that we have, and don't worry about them. There are a lot of pins, a lot of signals here. Gradually we work with every single signal here in this sketch, and we basically, this is the whole purpose of the project, to go through those and basically understand what pins does what and so on. So at this point we just define the pins as a variable and just assign the pin number on our Arduino Mega. All right, so now if you go down the list, there are a lot of pins and all of them are kind of defined, and we also have a function called reset pins, which is basically responsible for resetting everything to default, meaning that it's going to set the pins that are supposed to be output pins and also the pins that are supposed to be input pins. For example, the flag signals on this computer are normally input from Arduino's perspective, meaning that we probably are not going to set the flags manually. We are reading those flags from the system. Therefore, all of those pins are actually input pins from Arduino's perspective. Now, some of the pins could be output or input. We could change them on the fly when we run the sketches, but some of them are just either input or output pins. So in this section, I also have 2 functions at the bottom that I'm going to show you shortly, but those are the same. Those are, instead of going through pins one by one, for the bus pins and data pins, or excuse me, bus pins and address pins, I just have a little function at the bottom that basically it's a for loop, goes through the pins and just set them to input or output and so on. For the rest of the pins, we just manually identify those as output or input pins. And if we go a little bit further, you see that I'm actually setting a value on those pins, and every pin that is indicated as output pin, I get a value here, either low or high, depending on the pin. So that means basically we are resetting all the signals in our computer to default to whatever they're supposed to be. For example, the clock signal, we want to set it low initially, obviously, because we don't want to clock the system until we need it to. The HI signal here is an active high signal, so we set it low. Basically, we're not turning it on, and so on. But if you look at it, there are some signals there that are active low, and the signals that are active low are identified by a hyphen or an underline in front of the name, and that's basically means that's an active low signal. So therefore, I'm setting those as high initially, because that means that they are not active at this point. So as you can see, this function, basically what it does, it just sets the pin mode and then initialize the pin with either low or high. But if you look at it, we are not actually initializing any of the, for example, A pins or B pins. And A pins are the ones that are connecting to our A register, and B pins are the ones that are connected to B register. And the reason for that is that these are all input pins. We are actually reading something from those pins. So initially, we just initialize all of those, and this part of the sketch will be used pretty much in all our future testing, because this is how we initialize the computer or the module, and then of course we reset everything to the default so that we could start the test. Now these are the couple of functions that I was talking about a minute ago, and these are basically just a for loop to do a input or output on the either bus pins or on the address pins, because these are in sequence, so we could just, because we have an array actually at the top, we define an array, so we could just run a for loop and basically change all of them at once, rather than doing them one by one as we have to for the other pins. So hopefully these functions are clear here. Now if we move down, we have a setup function, obviously in any Arduino sketch, and that's where we start writing or calling our functions, and that's what is happening here. So for this specific build, we are basically testing the LED module or LED board. And this sketch is quite simple. What it does is basically just turns on all the LEDs and waits for a short delay and then turn them off. So this way we're gonna be testing a couple of things, right? So first we actually test the circuits for the Arduino Mega Shield and also for the LED board. And I mean, if everything works fine, that means that if those LEDs are actually turned on and off as expected, then that means the circuits are there, the connections are there, the soldering is fine. Also, the LEDs are okay actually. So that's a simple sketch that we're gonna do. So in this sketch, I'm just calling a couple of functions, and basically you see that the first function that I'm calling is that I'm resetting everything. We look at that function at the top, and then the rest of the functions essentially are just for testing different parts of the LED board. For example, the test register A LED is gonna just turn on and off the register A LED. So, and if you look at that function here, it's essentially just set the pin modes for all of those A register LEDs to output. And again, as I said, the A and B are normally inputs, but since here we are actually testing the LEDs, we want to light them up. We just convert them to output pins, and then we kind of set them high, and then wait for a delay based on a variable, and the variable is basically a delay time, and I set it to 100 milliseconds. And basically that's it. I mean, just brings up the LED to high and then waits for a short moment, and then basically at the bottom you see that I'm reversing all of those and kind of make them all low. So that's, for example, a simple test to do a testing on the LEDs and also the A lines. If you go to the B register, the same thing's happening, kind of exactly the same, except that now we are testing the B lines. And then for the bus lines, again, we have all the bus lines defined as an array. So we could just, again, use a for loop thing here, and basically just go through the for loop and set those bus lines to output or input. And also, we could basically write to them and turn on the LED and then turn them off. The same thing for flags, as you can see. And finally, the same thing for the address lines. And on top of that, I have a couple of functions, and also for the, of course, the control signals. For the control signals, again, the same thing. We're gonna change them all to output and bring them one by one, high and low. And the only difference is that here, as you can see, with the control signals, some of the signals are actually active low, and some of them are active high. So obviously for the ones that are active low, we have to, when we want to turn on the LED, we have to bring it low, and that's why, for example, on the B outline, we just bring it low, and that turn on the LED. And then the reason for that, as I explained before the build, is those two chips that we have on the LED board that actually are inverters, the 74HC04, that are inverting the signal. I mean, this signal is active low, so if you want to turn it on, you bring it low, and the LED it turns on. And of course, at the bottom, you could bring it high, and then that turns off the line. For the signals that are active high, we just bring them high, right? So that's how it works. And then again, at the end of the sketch, you see a couple of more functions, and those are for testing the switches. Yeah, remember that I talked about 3 switches on this board, and those switches are basically switch for resetting the Arduino, switch for resetting the whole system, and switch for the manual clock. So I have simple functions here. What this functions does is basically set the pins at input and just read the value of the pin. So if you actually press the button, then the value is true. I mean, basically you could read the value through a Boolean variable here, and you do a digital read on that specific pin, and if it's high, then it returns true, and basically on the serial line we just print that the manual clock is pressed. The same thing for the system reset, and these are the only switches that actually have a function here, because the other switch which actually resets the Arduino, we could just test it by pressing it, and if the Arduino resets, then we kind of pass the test. As you can see, for these two functions, I've created I'm basically calling those to the loop function, the main loop function in the sketch, meaning that basically we continuously are checking the status of those pins, if they are pressed or not, and if they are pressed, then we print that statement on the serial line. So it was a long description, sorry about that. I just wanted to introduce every part of the sketch, but let's run it. I guess the fun part is just running it and see how it works. I'm gonna just check the sketch one more time, and then I'm gonna upload it to the board. All right, so as you can see, the LEDs are actually turning on and off one by one on all the modules, and that's it. Basically, that's the test that we have done. Now, if you want to test the Arduino reset button, we just basically press the button, and that should just reset the Arduino and obviously reset the sketch. As you can see, that's basically resetting the whole Arduino thing, and then we kind of tested this switch already, right? So now we're going to move at the other testing, and for that I need to actually open the serial monitor. So I'm going to open the serial monitor, but that's actually restarting the whole thing. But let's wait for it. So once the LED testing are done, then I'm going to test the switches. So the first switch is the manual clock. So if I actually press that one, as you can see on the screen, if I move that here, I'm sorry. So if I actually press the button, you see that it's printing on the screen that manual clock is pressed. Now, if I press the other button, which is the system reset, then I see that system reset is pressed. So this way, we are actually testing almost everything on this module, and I guess this module looks like passed every test, and it's ready to go. So I know it has been a little bit long, and we have been building some LEDs at this point, nothing more than that. But trust me, those LEDs and those that Arduino shell is going to help a lot in the future testing. And this is basically our base for testing every module. So thanks for being patient, and stay tuned for the next module. We'll be building the clock module in the next video. I guess the excitement starts right there. All right, see you there.